On May 8, 2026, something began erupting beneath the Bismarck Sea near Papua New Guinea. There was no mapped volcanic island, no camera watching the crater, and no detailed chart showing exactly what existed on the seafloor. The first clear evidence came from earthquakes, strange sounds traveling through the atmosphere, and satellite images showing steam rising from open water. Within days, the sea changed color. Hot material appeared at the surface. Vast rafts of floating volcanic rock began spreading through the ocean, and two separate steam plumes emerged from an area where scientists lacked even a high-resolution map of the seabed. The eruption was happening approximately 125 kilometers southeast of Manus Island, along a poorly understood volcanic structure that local residents and researchers began calling Titan Ridge. It was also only about 16 kilometers from the estimated source of another submarine eruption detected in 1972. Scientists were watching an active volcano that had remained almost completely hidden beneath the sea. But the eruption soon became more than a geological mystery. Floating pumice reached inhabited islands, blocked boats, covered fishing grounds, and threatened communities whose food and income depended on the ocean. The event began quietly. Seismic activity had been recorded in the region on March 31 and again on April 25. Then on May 8, a small earthquake swarm occurred. Regional infrasound instruments detected signals consistent with the start of an eruption at around 1:15 in the morning. Infrasound is sound with frequencies below the normal range of human hearing. Explosions, volcanic eruptions, meteor impacts, and other powerful events can push pressure waves through the atmosphere over enormous distances. By comparing when those waves arrive at different stations, scientists can estimate where an event occurred. The signals pointed toward an area of open ocean roughly 82 kilometers south of Rambudio Island. Soon afterward, satellites detected plumes rising above the sea. That created an immediate problem. Scientists knew an eruption was happening, but they could not see the vent directly. The Bismarck Sea is tectonically complex and contains faults, spreading zones, volcanic islands, and underwater ridges. Yet the eruption site had not been mapped in enough detail to show the precise shape, height, or number of volcanic vents beneath the water. It was like watching smoke rise through the floor of a dark building without having a plan of the rooms below. Satellite instruments became the main source of information. NASA's Terra and Aqua satellites observed steam plumes, discolored water, thermal anomalies, and floating pumice. Other satellite systems helped scientists track the direction and extent of the material drifting away from the eruption. By May 15, imagery suggested that activity was coming from two separate vent areas approximately 2.5 kilometers apart. The eastern disturbed area was roughly 1.5 kilometers across, while the western area was closer to 500 meters. This did not necessarily mean two completely independent volcanoes were erupting. Magma can move through fractures and escape from multiple openings along the same volcanic ridge. Without direct seafloor observations, researchers could not yet determine the underground connection between the vents. The water above them provided clues. When magma erupts beneath the sea, its behavior depends strongly on depth. Deep underwater, enormous pressure suppresses the expansion of volcanic gases. Lava may emerge relatively quietly and form rounded structures known as pillow lavas. Closer to the surface, pressure is lower. Gas trapped inside magma can expand violently, and seawater can flash into steam when it contacts hot rock. Lava may fragment into ash, sand, rubble, and pumice. The Titan Ridge eruption appeared shallow enough to disturb the surface dramatically. Steam and gas plumes rose above the ocean, sometimes reaching several kilometers into the atmosphere. Water around the site became discolored by volcanic material, gases, and suspended particles. Then pumice began appearing. Pumice forms when gas-rich magma expands into a foam and cools so quickly that bubbles become trapped inside solid rock. Some pumice contains so many air-filled cavities that its overall density is lower than seawater. Instead of sinking, it floats. One piece of pumice may look insignificant. Millions of pieces packed together can form a floating sheet stretching across the ocean. Satellite images showed thick pumice rafts near Titan Ridge. Thermal instruments detected heat extending as far as approximately 2 kilometers from the source, suggesting that some of the newly erupted material was still hot and concentrated when it reached the surface. The floating rocks were then captured by winds, waves, and currents. A pumice raft does not behave like a solid island. It bends with waves, separates into long streaks, gathers again in calmer water, and can be spread over a much larger area than the original eruption. From space, it may resemble pale sediment, sea ice, foam, or a strange discoloration moving across the water. Individual pieces also change during their journey. Water slowly enters their pores. Algae, barnacles, microbes, and other organisms begin colonizing the surfaces. Eventually, many fragments become heavy enough to sink. That process can take months or even years. Until then, the raft remains mobile. As the Titan Ridge pumice drifted toward the Admiralty Islands, the eruption's effects reached coastal settlements. Residents reported thick accumulations along parts of Manus Island. In some places, pumice piled 2 or 3 meters deep near the shore. Boats could not move through it safely. Engines risked drawing volcanic fragments into their cooling systems. Fishing areas became inaccessible or covered, and travel to larger towns for supplies and services was disrupted. For communities that depend on fishing both for food and income, an eruption more than 100 kilometers away suddenly became a daily emergency. Villagers began clearing pumice manually. Some of the material was placed in swampy areas or used to level ground, but the total volume was far beyond what small communities could quickly remove. The pumice itself was not highly poisonous simply because it was volcanic rock. The greatest immediate danger came from its physical presence. It could block shorelines, trap boats, cover reefs, interfere with fishing, and isolate settlements. Residents near the eruption also reported dead fish, metallic smells, and sounds resembling thunder. Submarine eruptions can temporarily alter water temperature, acidity, oxygen levels, and chemical composition. Ash and fine particles may damage fish gills, while volcanic gases and heated water can make conditions locally hostile to marine life. The long-term ecological effects remain uncertain. Pumice can smother shallow habitats when it accumulates densely, but floating pumice also becomes a transport system for life. Organisms attach to it and travel across oceans, sometimes reaching islands thousands of kilometers from where the rock formed. After previous large submarine eruptions, scientists found pumice carrying complex communities of algae, mollusks, corals, worms, and other organisms. A destructive volcanic event can therefore become a temporary floating habitat and a mechanism for dispersing species. Titan Ridge presents scientists with a rare opportunity to study this process from its beginning. Satellites recorded the eruption, the creation of pumice, and the movement of the rafts. Future sampling could reveal how quickly organisms colonize the rock where it travels and when it finally sinks. The event may also be changing the shape of the seafloor. Every eruption adds material around its vent. Lava flows, ash, shattered rock, and pumice fragments can gradually construct an underwater volcanic cone. If repeated eruptions build the summit faster than waves and currents erode it, the volcano may eventually reach the surface. This is how some volcanic islands are born. However, scientists do not yet know whether Titan Ridge is close enough to sea level or producing enough stable material to create a lasting island. Satellite images can show what reaches the surface, but they cannot provide a detailed picture of the structure accumulating below it. A temporary patch of material may emerge and then disappear. Newly formed volcanic islands are often made from loose ash and fragments that waves can destroy rapidly. A permanent island normally requires enough solid lava to resist erosion. For now, the possibility of new land remains open, not confirmed. The eruption has exposed a much larger gap in human knowledge. Satellites have mapped the surfaces of the Moon and Mars in remarkable detail, but large areas of Earth's seafloor are still known only through low-resolution estimates. An unmapped submarine volcano can erupt, produce atmospheric plumes, release kilometers of floating rock, and affect inhabited islands before scientists know its precise shape. The 1972 event near the same location shows that Titan Ridge may not be newly active. Instruments at the time detected underwater acoustic signals resembling those from volcanic eruptions. But without modern satellites, dense monitoring networks, or detailed mapping, researchers could reconstruct only part of what happened. More than 5 decades later, another eruption began in nearly the same region. This time, satellites provided a continuous view from above, but the seafloor itself remained hidden. A ship equipped with sonar could map the volcanic structure before and after the eruption. Remotely operated vehicles could photograph lava flows, collect rock samples, measure temperatures, and search for hydrothermal vents. Chemical analysis could reveal the magma's origin and explain why the eruption produced so much pumice. These observations would help scientists answer the central questions. Is Titan Ridge one large volcano or a chain of vents? How much new material has accumulated? How shallow is its summit? Could another eruption produce a tsunami, a temporary island, or even larger pumice rafts? Until direct surveys occur, the eruption will continue to be understood mainly through clues visible from space and reports from nearby communities. Titan Ridge is a reminder that a volcano does not need to tower above a city to change human lives. It can remain invisible beneath the ocean, reveal itself through sound and steam, and send its products far beyond the eruption site. The sea hid the volcano, but it could not contain the eruption. In May 2026, magma rose through an unknown section of the Bismarck seafloor. Satellites watched the ocean discolor, 2 vent areas appear, and vast quantities of pumice spread outward. Weeks later, the floating rock reached island communities and transformed their coastlines. Scientists are now watching to see whether the eruption will fade, continue rebuilding the ridge, or eventually create a new piece of land above the Pacific. Whatever happens next, Titan Ridge has already shown how much of Earth can remain invisible until the planet suddenly forces it into view.